Hi everyone, welcome to lecture 29 of your electric circuit class. And lecture 29 is about instantaneous and average power. The objectives out of this lecture is to determine the instantaneous power and to determine the average power. In AC circuits, the power is different compared to DC circuits. So power in AC circuits. First, let's say that our voltage, we can express it as V of t is equal to Vm cosine omega t plus theta V, and that is in volts. And I of t is equal to Im cosine of omega t plus theta I. As you know that this is the general form of the sinusoidal, let's say, voltage and current. So theta V here is the phase angle of the voltage, and this is the phase angle of the current, which is theta I. And that is, of course, in ampere for the current. So now we can say that if you look at these two expressions, these are time varying expressions. So if the voltage and the current vary with time, then we can say the power will vary as well. So the time varying power is called instantaneous power. So instantaneous power is the product of the time domain quantities of voltage and current, and that is measured in watts, which is simply W. So now from that, since we are saying that it is the product, that means P of t is equal to V of t times I of t. So we said that V of t, it is Vm cosine omega t plus theta V, and I of t is Im cosine omega t plus theta I. So let us substitute here. So that is equal to Vm cosine of omega t plus theta V times Im cosine of omega t plus theta I. So this is equal to Vm Im multiplied by cosine of omega t plus theta V times cosine of omega t plus theta I. So if you look at over here that we do have two cosine quantities multiplied by each other. So if we use the identity, which is cosine A times cosine B, that is equal to 1/2 multiplied by cosine of A minus B plus cosine of A plus B. That means, excuse me, that means this quantity here, omega t plus theta v, we are going to consider it as A, and omega t plus theta I, we are going to consider it as B. So doing that, we are going to get our P of t is equal to 1/2 Vm Im multiplied by cosine of omega t plus theta v minus omega t plus theta I plus cosine of omega t plus theta v plus omega t plus theta I, and that is our quantity. So now let us just simplify a little bit. That is 1/2 Vm Im multiplied by cosine of omega t plus theta v minus omega t minus theta I plus cosine of omega t plus theta v plus omega t plus theta I. So this omega t will cancel with that omega t. So we will have 1/2 Vm Im multiplied by cosine of theta v minus theta I plus cosine of, I have omega t and omega t, that is 2 omega t plus theta v plus theta I. So if we look at this, we can get our final form as P of t is equal to 1/2 Vm Im multiplied by the first term, which is cosine of theta v minus theta I, plus 1/2 Vm Im multiplied by the second term, which is cosine of 2 omega t plus theta v plus theta I. And that is, of course, in watts. So this is the expression for our instantaneous power. So this is the instantaneous power expression. The reason that we are saying instantaneous, because if you look at the expression, I do have over here a term t, which means that we can find the power at any instant of time. So let us go over an example over here. And we would like to derive the equation for voltage and instantaneous power in the circuit. And this is our circuit here. The current over here is given as a phasor, 2 with angle 25 degrees, and that is in ampere. This over here is 4 and J4 ohm. And this is where we need to find our voltage V. So first of all, our solution over here, we can get our V is equal to I times Z, which is equal to 2 with angle 25 degrees multiplied by the impedance, which is 4 plus J4. And the answer here is 11.3 with angle 70 degrees. And that is in volts. So that is our V. So if I want to get this V in time domain, that will be 11.3 cosine of omega t plus 70 degrees. This is here time domain. So current in time domain is, we have it as a phasor, which is 2 with angle 25. So I of t in this case is equal to 2 cosine of omega t plus 25 degrees. That is in ampere. So this is here time domain quantity for the current. So now to get our instantaneous power, we should have both to be in time domain. So the V is in time domain and the I is in time domain. So that will be V of t times I of t. And that is equal to 1/2 Vm is 11.3, Im is 2, cosine of theta V is 70, and theta I is 25, plus 1/2 times 11.3 times 2 times cosine of 2 omega t plus 70 plus 25, which is in this case that is equal to 11.3 cosine of 45 degrees plus 11.3 cosine of 2 omega t plus 95 degrees, and that is in watts. And the final form is 11.3 times cosine 45 degrees, that is 8, plus 11.3 cosine of 2 omega t plus 95 degrees. And this is our instantaneous power expression, the instantaneous power expression. Over here the question is saying that derive the equation for voltage. This is our equation for the voltage. So now we will move on to what we call average power. When we are saying that average power, that is the same if we say active power, or the same as if we are saying real power. So average, active, real, that is the same term. So we can say here real power or average is the average value of the instantaneous power. And it is also measured in watts. So now, by looking at our instantaneous power equation, that came out to be 1/2 Vm Im cosine of theta v minus theta I plus 1/2 Vm Im cosine of 2 omega t plus theta v plus theta I. That is the instantaneous power equation. So if you look at this here, I do have two terms. This first term here, that is constant, because there is no t in it. So if I substitute the value of Vm, Im, theta v, and theta I, it will be a constant, a number. And the average of a constant is the constant itself. And if I look at this here, that is a sinusoidal, let's say, waveform or signal. So over here, average of a sinusoid is 0. And from the definition, since we are saying that real power is the average value of the instantaneous power, that means this is our average value over here. So that will give us our P is equal to 1/2 Vm Im cosine of theta v minus theta I. And this is the average power. So we would like to note the following. The first one, for pure resistor, theta v minus theta I will equal to 0. That is because I and V are in phase, so they will have the same angle. So from that, cosine of theta v minus theta I is equal to cosine of 0, which is equal to 1, which means in this case resistors absorb average power all the time, or all the time, or always. So always that they will absorb average power, because cosine of 0 is 1, then we will have a value for that expression. The second one, that is for pure reactance. What we mean by that, pure C or pure L. In this case, our theta v minus theta I is equal to plus or minus 90 degrees, exactly 90 degrees. And from that, cosine of theta v minus theta I is equal to cosine of plus or minus 90 degrees, and all the time that is equal to 0, which means that reactances do not absorb average power at all. Because look at our average power. If I have that to be pure, let's say, inductance, then theta V minus theta I, that will be what? That will be positive 90 degrees, and then that will be 1/2 Vm Im times 0. It will be 0. So now here are some equations that can be used to determine average power. P is equal to 1/2 Vm times Im. What we mean by that? What we mean by that is the following. If I have a resistance here, the current flow in here is I, which is equal to Im with angle theta I, and then I have a voltage across this, which is equal to Vm with angle theta V, and in this case that theta V is equal to theta I. So that's why we do not have over here the cosine. So in this case you can use 1/2 Vm Im to see how much average power that resistor is absorbing. Or you can use this equation, that P is equal to 1/2 Im squared times R. And in this case, if I have, for example, this, that is R, this is Jx. If I know the current flow in here, which is I, that is equal to Im with angle theta I. Then if I take the magnitude of that current and I square that and multiply it by 1/2 R, I will get the average power. And the last condition here, or the last case, that is 1/2 Vm squared over R. In this case, if I have this, let's say that is R, this is Jx, I have to know what is the value of the voltage across the resistor by itself. That is Vm with angle theta V. We cannot take the voltage across the whole thing, okay? We take the voltage across the resistor by itself, then we can use this equation over it. So let us go over an example. We would like to determine the average power absorbed by the 4 ohm resistor. And this is our circuit here. That is 4. (12) with angle 90 degrees volts. This is J2. This is 2 ohm. This is 4 with angle 0 minus J4. So we would like to know how much power that this resistor absorbs. So we can put this as node 1. We can put this as node 2. So we can say that at node 1. At node 1, that is V1 over 4 plus V1 over negative J4 plus V1 minus V2 over 2 is equal to 0. We have one more term, minus 4 with angle 0, and then that is equal to 0. So we found the current over here, the current over here, the current over here, and the current over there. This node here, since there is only short, that is V1. So now we can simplify and get these terms. So that will be V1 plus JV1 minus 16 with angle 0 plus 2 V1 minus 2 V2 is equal to 0. What I have done over here, that we multiply by 4. So collect terms, that will be 3 plus J1 times V1 is equal to 2V2 plus 16 with angle 0. And this is our first equation, let's say. And if you look at V2, which is node 2, V2 is equal to 12 with angle 90 degrees. It's a super node. So now just substitute V2 is equal to 12 with angle 90 degrees in equation 1. We are going to get 3 plus J1 times V1 is equal to 2 times 12 with angle 90 plus 16 with angle 0. So from that we can solve for V1, which is 16 plus J24 divided by 3 plus J1. And the answer here is 9.12 with an angle of 37.87 degrees, and that is in volts. Our I1 is equal to V1 divided by 4, and that is 9.12 with angle 37.87 divided by 4, which is equal to 2.28 with an angle of 37.87 degrees, and that is in ampere. So now we can say our P of T is equal to 1/2 Vm Im, since that is a pure resistance, and that is equal to 1/2 Vm is 9.12 times 2.28, and the answer here is 10.39 watts. We may use P of T is equal to 1/2 Vm squared divided by R, because it is only a resistance in that branch, and the whole voltage, which is V1, that is the voltage across that 4 ohm resistor. So that is 1/2 V1 squared divided by R, and that is 1/2, and we said that the V1 is 9.12 squared divided by 4, and then we will get 10.39 watts, which is the same as before. We can go with another example here. Determine the power absorbed by each resistor in the circuit. And our circuit is like this. This is 12 with angle 0, 20 ohm. We have a current source here which is a 3 with angle 0. Another resistance which is 20. And this is our circuit over here. So we would like to find the power absorbed by this resistor and by that resistor. If I know the current flow through each of the resistor, then I can use 1/2 Im squared, right, multiplied by the resistance. So we can have this as I1 and this over here as I2. Then based on that, we can write for both loops here, so loops 1 and 2, because that is a super mesh. The first equation, that is I1 minus I2 is equal to 3 with angle 0. That is our first equation. Then the second equation, that is negative 12 with angle 0 plus 20 I1 plus 20 I2 is equal to 0. That means 20 I1 plus 20 I2 is equal to 12 with angle 0. And this is our first, our second equation. So now solve these two equations. This is what we are going to get. We are going to get I1 is equal to 1.8 ampere, and I2 came out to be negative 1.2 ampere. So now the P, if I call this as P1 and this is as P2, then P1 is equal to 1/2 I1 squared times R, which is 1/2 I1, that is 1.8 squared times 20, which is equal to 32.4 watts. And the other one is P2, 1/2 I2 squared times R. So 1/2 I2 is negative 1.2 squared and R is 20. And the answer over here is 14.4 watts. So now, since we have only resistances over here, that means the resistances will absorb the power of the total for both of them, 32.4 plus 14.4. That means this circuit is really supplying a total power of the summation of P1 and P2. Don't forget that. By this, it is done for the circuit for the lecture for today. And this is the homework set that you need to solve for this lecture. 3 problems, they are simple and straightforward. Thank you for watching.